Running an analysis in Sherlock is very straightforward. Navigate to the left-hand panel here where you'll see the Analysis tab. Underneath that you'll see all the different types of analysis that Sherlock can run. To run an analysis, right-click on it. For instance, in this case I'm going to choose solder fatigue, go to Edit Properties, and all you need to do is fill in the form with the analysis properties, select your inputs. In this case I'll select this thermal event and click Save and Run. And now the solder fatigue calculations will occur behind the scenes in Sherlock. If I wanted to do plated through-hole fatigue, I would right-click on that as well, Edit Properties, fill in the form for the plated through-hole analysis, which you see have different fields, select my event again, and click Save and Run. These two run in the background within Sherlock. If I wanted to run a natural frequency, for instance, which is a mechanical analysis, the form once again you see is a little bit different. We have our analysis properties at the top, but in this case we have down the bottom here our modeling section, which shows us how we can model all of the different components and elements of the board. For most users, only a few of these will be relevant to you. You normally model the PCB, which is the board itself, the mount points or the mounting conditions for the board, and usually the parts as well, or the components on the board. And you can see as I click through these, I can choose whether I want to model something or not. So if I don't want to model leads, I can click on that and disable lead modeling. I suggest that you start with the standard default values in here. What we want to do is make sure that we can have a model that runs first, and then once you get a stable model that runs, you can play with the mesh settings and refine your mesh to get a cleaner and cleaner result. So I'm going to leave the default settings and click Save and Run, and Sherlock will run the natural frequency analysis as well. Once an analysis is done, you can double click on it. So for instance, my solder fatigue, I can double click on it to open my results, or I can right click and select View Results. That will bring up this results window for me, where you'll get this first summary slide with a scoring for your analysis. You see three colors, green, yellow, and red. Green is good, yellow is okay, and red is something that may be problematic. We also have our analysis statistics. So you have all of that here, your reliability goals that we set earlier in our life cycle, as well as the board properties. This is the slide for directors that you would send to your manager, enabling a quick snapshot of what the results are. Down the bottom here, you'll see the other ways that the results can be displayed. So if I move from my summary tab to my life prediction tab, here you see my life prediction curve. So once again, we have our reliability goals written up the top here that came in from our life cycle, as well as a box to graphically represent that on the screen. And you can see this curve here represents the life prediction of our board. So you can see that our board barely reaches 1 year of life by the time it crosses over the 3% probability of failure goal. Ideally, what we want is to not cross over this line until after we've reached 4 years. So this would require us to have a further look as to why the life prediction is the way it is. We also have a graph with time to failure broken into the number of components, so you can see where the components are spread and what number of components fall in terms of their time to failure. So you can see that we have quite a few here that fail before our service life, and we also have some that exceed 2x or 2 times our service life, and then some that even, the green ones, exceed 5+ x of our service life. If I move to the table, you'll see we have a table for every single component on our board here, once again color-coded in the red, yellow, and green to indicate whether they have been good, they're just okay, or if they've failed. And what I can always do with any table in Sherlock is right-click, export table, and I can export all of this data directly out into a CSV file. What I can also do is right-click, view part properties, and verify the part properties that we used for this calculation. So once again, I can see all of the different part properties. I can also see where these properties came in from and were read in from and were used for this analysis. I can view the 3D model for that particular part if I click View 3D Model, and view how that model would be represented. Lastly, if I'm only interested in the life prediction for a particular part, I can always right-click on that particular part and choose View Life Prediction, which will give me a life prediction curve just for that individual part. And you see that this part by itself does not even meet our 4-year 3% goal. As my analyses finish running, you'll see that they begin to populate themselves on this tab on the left-hand side. So I can now click on my natural frequency results, and once again you see we get a summary slide with our analysis properties as well as our board properties. And we also get a table here with the results of our natural frequencies. Once again, at any table in Sherlock, I can always right-click and export that table as a CSV file. With natural frequency being a mechanical model as well, we don't just get these natural frequencies given to us as a table, but we can actually view them visually. So if I actually go back and right-click on my natural frequency results here and click on View Layers, I can view my natural frequency results in the 2D layer viewer. And as you can see, I can switch from my first to my second natural frequency to my third and view how the natural frequency shape changes. What I can also do is view these results in 3D. If I right-click on natural frequency and go down to View 3D Results, Sherlock will launch the Sherlock 3D viewer, and that will read in our natural frequency results and display them in 3D for us. So if I select my first natural frequency, you'll see that the coloring matches that on the layer viewer that we saw just previously. But we also get a 3D mode shape for this first natural frequency. I can switch to the second natural frequency, hit refresh down the bottom here, and it'll re-render my model to the second mode shape. With any 3D results in the 3D viewer, I can always take a quick snapshot of this by clicking this little camera button down the bottom here. If I click this, I can save this as an image file, or I can even save it as a PDF. All I need to do is name it, click Export File, and you'll see that Sherlock will save it as a PDF and launch the PDF in a PDF reader with the 3D model in it. So I can actually click, zoom, and interact with this model if I wish. I can then send this PDF to my colleagues or to my manager, and without even having Sherlock on their machine, so long as they can open a PDF, they can view my results, my 3D results, right here. What I can also do is save everything that's in this window by going to File, Save As, and I can save these 3D results, which I can also send to other members of my team. 3D results open up in the Sherlock 3D viewer, which is a license-free software. So if you have Sherlock installed in your machine, you can open the 3D viewer without having to pull a Sherlock license. What I can also do up the top here is I can turn on and off features in this graphical viewing area here. So if I didn't want to view my parts, I can uncheck them here, press refresh, and you see I just see the results for the board itself. Or vice versa, I can turn the board off and just view the parts. Once my results have come in for all of the analysis that I've run, what I can also do is generate a report very quickly in Sherlock. If I go down to results here, once again I can view my life prediction directly by double clicking on the life prediction tab, and that'll open up the combined life prediction of the different analyses that I've run, as well as putting their individual ones too, and you can correlate that to the legend here on the right. To create a report, all I would need to do is right click on report here, go down to generate report. It opens up this window with the report settings. I can fill in some details, so I can put my name in the author field as well as my company details, and select which results I wish to include in the report. In this case, I'm going to select all of them and then just hit generate report. Sherlock automatically generates this report for us, as you can see, and it's saved as a PDF, which once again I can always share with my colleagues or send to my manager. As I scroll through, you can see that every result that I've run so far is included in this report. So I've got my life prediction curves, my overall component scores, location of the components that failed, location of the plated through holes that failed, as well as seeing my board design, my stack up data that I viewed earlier, my natural frequency results, and even the layer viewer of my natural frequency results. So I get my first and my second natural frequency and so forth. So this report is automatically generated, as you saw, in a matter of seconds, and I can share these results with members of my team. Once I'm done, I can also save my Sherlock results. If I wish to share them with someone and let them go in and click around Sherlock. What I can do then is right click on Save Results down the bottom here, select Save Results, give it a name, and save my analysis results. Once my results have been saved, you see a window pop up that says, confirms that they've been saved, and you can see under Save Results, I actually have a set of results. So this is quite handy if I want to go back and make some changes. I always have my initial results here to go back and compare my new results with. To view these results, I can just right click, go to Show Location, and you see that this is the Sherlock results file, which I can share with my colleagues. If I double click this, it opens in the Sherlock results viewer, which is very, very similar to the results viewer that we saw within Sherlock. It just doesn't allow you to make any changes. So once again, we get our scorecard, we have our life prediction curve, our natural frequency results with the summary tab, the natural frequency result tab as well. If I go down to solder fatigue, once again, we get our summary tab, our life prediction tab, our time to failure graph, and our table with all the results. And I can right click and view the individual life prediction like I could in Sherlock. All of that is here. I also get my parts list, so I can see which parts I've used in this particular analysis for this particular run, and I can right click and view the part properties and have a look at what properties I've used for that analysis also. All of the results and all the information in this run is saved in this results file, and that can also be attached to this particular project. So I can go back now and change my components, move them around, change materials, run them again, and I can always compare them back with these sets of results.